Hello and welcome back to chemistry practice. In the last video we looked at percent yield, and they were very standard percent yield sort of questions. At the end of the video I mentioned that chemistry teachers really like to make the questions a little bit more difficult in quizzes or tests by throwing you information from previous units that you may not have actually reviewed recently. And this is why information in previous units is important to remember, and it's important to go back and review consistently in chemistry. So let's go ahead and look at this percent yield question. Use the balanced equation, so we know this is balanced, to find out how many liters of sulfur dioxide, here's sulfur dioxide, are actually produced at STP, which is standard temperature and pressure, if 1.5 times 10 to the 27 molecules of zinc sulfide are reacted with excess oxygen and the percent yield is 75%. Wow, so this is a little bit different than what we did last time, but it's actually completely the same. So what do we know? We have 1.5 times 10 to the 27 molecules of zinc sulfide. We also know we need to figure out how many liters of sulfur dioxide we're getting. So this is sort of a standard stoichiometry problem. Remember your conversion factors. I know that 1 mole of any substance has messing up here already, of any substance has 6.02 times 10 to the 23rd representative particles of that thing, so it could be molecules or atoms. I know that 1 mole of any gas is 22.4 liters in volume. I know that 1 mole of anything will equal its molar mass. So there's a lot of conversion factors I can use here. I'm going to have to use both of these to answer this problem, which makes this problem a little bit more difficult. So let's start out with what we are given. We're given 1.5 times 10 to the 27 molecules of zinc sulfide. Let's convert this to moles. 1 mole of zinc sulfide equals 6.02 times 10 to the 23rd particles of zinc sulfide. Now let's build our ratio. We have 2 moles of zinc sulfide, so 2 moles of zinc sulfide will equal 2 moles of sulfur dioxide. Now our answer has to be in liters because it asks for liters right here, and that is good because we have a gas. Otherwise we could not use that liter conversion factor. So I know 1 mole of sulfur dioxide equals 22.4 liters of sulfur dioxide. Let's go ahead and see if our units cancel. We have moles of zinc sulfide. Molecules of zinc sulfide. These are molecules. These are moles of zinc sulfide, moles of zinc sulfide, moles of sulfur dioxide, and moles of sulfur dioxide. So in the end we should get liters as our units, liters of sulfur dioxide. So if we do this math, 1.5 times 10 to the 27th divided by 6.02 times 10 to the 23rd, and you could actually just skip this step since it cancels out 2 over 2. So take this, then multiply it by 22.4. I should get 5.58 times 10 to the 4th liters of SO2. And it's important to, once you get your answer, you have to convert back into scientific notation. Sometimes that's going to confuse students, so you need to go back and look about how do I convert to and from scientific notation. Okay, but we're not done yet. This is the theoretical yield in liters of SO2. I've been given a percent. So in our other problems, we were given an actual yield. Instead, now I have this percent, so what do I do with that? Well, I know one thing. I didn't get this much of SO2 when I did this experiment. I got 75% of this number. So whatever my answer is has to be less than this number. And if I think about it, my percent yield equals my actual yield over my theoretical yield. So I could go back and substitute in these numbers and then do a little bit of math. So my theoretical yield, what I should have gotten, is 5.58 times 10 to the fourth. My percent yield, my percentage of what I actually got is 75%. Now here's where people make a mistake. They put 75 right here. But we have to convert percent back into a decimal form. So this should be 0.75. And to do that, I would take 75 divided by 100, and this is 0.75. So my actual yield is the unknown. So as you can see, if I rearrange this equation, I'm really going to get 0.75 times 5.58 times 10 to the fourth, and that should give me 4.18 times 10 to the fourth liters of SO2. And it said how many liters of sulfur dioxide are actually produced at STP. And this is the answer right here. This is our actual yield. Okay, let's move on to one more question. Some underwater welding is done via the thermite reaction, in which rust reacts with aluminum to produce iron and aluminum oxide. In one such reaction, 258 grams of aluminum and excess rust produced 464 grams of iron. What was the percent yield? Okay, first of all, they give us a whole lot of extra story here, and it's nice, but we don't need it. In fact, I could just sort of cross that out. And this is more of a standard sort of mass-to-mass stoichiometry. They give us 258 grams of aluminum. And we need to know how much iron is produced. So they're giving us aluminum. We need to know how much iron is produced. This is a mass-to-mass stoichiometry. As you notice, nothing here is a gas. They're all solids. So 258 grams of aluminum, 1 mole of aluminum equals 26.982 grams of aluminum. Let's build our mole ratio. 2 moles of aluminum should equal 2 moles of Fe iron. Now let's take iron back to grams. 1 mole of iron will equal 55.847 grams of iron. So if I do this math, 258 divided by 26.98, I could skip this step since these are equal, times 55.847, I'm going to get 534.0 grams of iron. So this is my theoretical yield, what I should get. But I got 464 grams of iron. So they give me the actual yield. This is the actual yield divided by the theoretical yield times 100 equals 86.89%. And that is my percent yield. Okay, well, I hope that helped a little bit. If I have time, I'll try to make one more video and run over a few other exceptions, but I think that's enough to cover most things on quizzes or tests at this level. So thanks for tuning in. Talk to you later.